Okay, so here we have two shapes. We have a rectangle and we have the triangle. Well, technically, you could do two triangles, yes, or one large one. It's probably easier if you do one large one. With the rectangle, the formula for a rectangle for area is length times width or base times height. It's fine. So your substitution would look like, do I have to put my units in?
Yeah.
But do I have to put units? No. Not till the final answer. So 6 times 8 or 8, well actually 8 times 6, but yeah. Which is 48. And now I put my units of feet square. Formula for a triangle? Base times height divided by 2. Or 1/2 base times height. Better. So the base, if we're doing this large triangle, what's that length here, the base length? 6, because it's the same dimension as the bottom, right? So 6 times the height is 4 divided by 2, which gives you 12 feet squared. So your total area here is 60 feet squared. We add them together. Okay, pretty simple. Totally simple when it's two-dimensional. When it's three-dimensional, it's a lot tougher to visualize. Now, in this case, it says find the volume of the tool shed to the nearest cubic foot. Okay, so there's the top portion. The top portion, when you open up the top portion, what shapes are those? Triangles. And are they going to be the same dimension? Yes. So this is 6 feet, right? We know its vertical height is 4, but when you open up the net for the triangle, I'm just doing the top right now. It's the 4 triangles here, these guys. Okay. When you open that up and you lay down the net, the height of the triangle, would it be 4? No. We want specifically the slant height. That would be the height of the triangle. Okay. We want specifically the height of the triangle. So what would that be? Well, it's the same shape we actually have up above here. But if we wanted to figure it out, we could, because what would this dimension right here be? 3. Because this is 6 feet, the full length, halfway would be 3. And so using Pythagorean, 3 squared plus 4 squared equals c squared. 9 plus 16, what does 9 plus 16 equal? 25. What's the square root of 25? 5. Okay, it's a 3, 4, 5 triangle. If your base and your height, or your base and your altitude are 3 and 4, hypotenuse is 5. It's the coolest little triangle, I think. Oh, we just have to find volume. I should read the question. Right? I shouldn't assume things. Hey, we have to do surface area down here. Thank you. So let's do surface area first, because it's way harder. Don't you agree? No? Surface area is way more work. Okay, well, we'll come back to the volume after. Well, you can still write top. We're going to still do top and bottom. Okay, so surface area. We have the 4 triangles, right? Now, if it's a tool shed, do we need the bottom of this tool shed? No. Okay, so we need the 4 triangles, right? So the top is going to be 4 triangles. 4 times the area of one of the triangles. So each triangle, what's the base of the triangle? 6. What's the height of the triangle? 5 divided by 2. Base times height divided by 2. Does everyone see how? I probably should have wrote that formula. Yeah, sorry. Go away. So if you want, what I was doing here is 4 times base times height divided by 2, right? And if you understood that, then we're good. 6 times 5, 30 divided by 2. 15 times 4 is 60 feet squared. Okay, so the 4 triangles would equal 60 feet squared, their area. That's a coincidence. Actually, it actually is. Okay, what else do we need to include in this area? We said we do not need to include this base. The base here is not included. Do we need the, if we look at that, so that's the bottom of the shape, it's, what shape is that? Is it a cube or a rectangular prism? Rectangular, right? Because the height is not 6. It's 6 by 6 by 8. So technically it's a rectangular prism because not all 3 sides are the same. Do you need the top of the rectangular prism? No. And the bottom? No. We just need the 4 sides. Are the 4 sides going to be equal, the same? Yeah. So it'd be 4 times the area of the rectangle. They're 4 equal sides. All 4 of them have dimensions of 6 by 8. 6 by 8. So formula for a rectangle you told me was length times width. So 4 times length is, this is not drawn to scale, hey? Because 8 looks smaller than the 6, doesn't it? Or not, like, yeah, anyways. Oh, well, and also it's not drawn to scale because, oh, what am I doing? Okay. Length times width. So 6 times 8. Agreed? Or 8 times 6. Same thing. 6 times 8 is 48. Times 4 of those is what? 192. So the total surface area is what? Adding them together. So we add them together. 252 feet squared. So we want exposed area when we want surface area. If this shape did not have a context to the question, so I didn't tell you it was a tool shed, it was just a shape that I handed you, then would the bottom be exposed area? Yes. So only in the context, the contextualized problem of it being a tool shed do we not, because that won't be exposed, right? Yeah. Well, if this was, oh, this, no, so the top of the, you wouldn't include the top still of the rectangular prism because that's not exposed either way. Whether, because if I give you this as one object, it's never going to be exposed.
Basically, so like when you're talking about surface area or something that would be sitting against the ground, it's how much, like, if you were to 4 feet over it,
Yes.
how much of the shape would be.
Exactly. So if the shape, if it is a contextualized problem and it's sitting on the ground, if you pour anything over on top of it, paint is a great example. How much of the paint would be covered? Like where would it be covered? That's where you're finding your area. Okay. Volume, we have 2 shapes. What's the shape on top? Triangular. No, it's not triangular. It's a square. No, the top? Square pyramid! Yay! Okay. It's a square pyramid. Grab your formula sheets. What's the volume formula for a square pyramid? 1/3 length times width times height. Okay? It's really the same formula as a rectangular when it comes to volume. Pyramid. So formula substitution, length is 6 times 6 times. What's the height of the pyramid? 4. So we're looking at just the pyramid right now. So the length, the width, and the height of the pyramid. Okay? What does that equal? 48. Feet to the feet cubed. Bottom, what shape is that? Rectangular, we just prism. What's the formula for that? Length times width times height, or area of the base times height, same thing. So for the prism, it would be length, width, and we're talking about the prism height. So this is our prism height. No, don't do that. Just you and one highlight. Close enough. Oh, you heard? That's leadership. They need to soundproof my floor. Sorry. Well, maybe. 6 times 6 times 8 is 288 feet cubed. And so the total, we would add those two together, and that gives me 336 feet squared. Cubed, thank you, cubed. Would be total volume. All right, only 2 more examples. Okay. I'm again going to get you to do this first one, okay? So really, this looks like a running track. It kind of also looks like a skating ring.
It looks like a ladyfinger.
Yeah, looks like a Band-Aid, sort of.
It looks like a ladyfinger.
Okay, yeah. All right, so what I want you to do, guys, is find the area of this shape. Now, break it down. What are the 2 shapes that it actually is enclosed or in? A rectangle and 2 semicircles, but if you push them together, 1 circle. Okay, so find the area. Okay, should we separate you? One of these? Okay, so area is length times width for a rectangle. Circles pi r squared. Length would be 100 times 64. What's your radius? 32 squared. When you add those together, what do we get? Okay. So when you add this together, total area is equal to 9,617.0 meters squared. Okay, so we can take that same idea and apply it to a 3D concept. So instead, what 2 shapes? Yes. Oh, so the area of a circle? Because you have a hemisphere plus another hemisphere, and if you push them together, they create a circle. No, the formula for 1 circle is pi r squared. The area of any circle is pi r squared. Look in the formula. No, you're thinking of a sphere. Just a circle. Okay, got it. Oh yeah, the magic beads, and they would, yes, totally. Those are weird. Okay, so what 2 shapes do I have here? If I think of it as 2 shapes, we have a cylinder, the volume of the cylinder, plus, so total volume is volume of the cylinder plus the volume of, well, we have 2 hemispheres. We push them together, it's a sphere. The volume of the sphere. Or like something that you cut in half that was spherical, and then you put it back together. Okay, so what is the formula for the volume of a cylinder? Pi r squared h. And what's the formula for a sphere, volume of a sphere? That's on your formula sheet. 4/3 pi r cubed. So we have to be careful. Well, I don't know how careful, but this is the cylinder and the sphere. Do they have the same radius? Yeah. Okay, what is the radius? 1.5. 1.5. So 1.5 squared. What is the height of the cylinder? 8. Right? Because technically you can think of this as a circular prism. Right? Because it's a prism in the sense that the two shapes that are parallel to each other, the base would actually be the circles. And then you have the one rectangle connecting it. Okay, plus 4/3 pi times 1.53 cubed. Could we type this in all at once? Why not? Okay. I wish there was a view button. Nope. Anyone can get it. Okay. So I'm just gonna detach. So let's type this in. Over here. Okay, so we're typing this in. Sorry. Clear. Clear. Hey. Oh gosh. Can you see this all right if I type it in small? Or do I need to make it bigger? Pi 1.5 to the power of 2 times 8 plus 4/3 pi and 1.5 to the power of 3. Something like that. Okay? Gives you, and that's our answer. To the nearest 10th? 70.7 feet cubed. Okay? Now the fun part.
Yes. I love fun parts. That doesn't sound like
Okay. Surface area. Do you want to try this one? Okay. I want you to try it. The surface area.
No, never mind.
Okay. So, if we have two parts. First of all, the sphere, right? We push the two parts to get the top and the bottom. We have a sphere. The surface area formula for a sphere is 4 pi r squared. So most of you were good with this. 1.5 is your radius, right? And that gives you 28.3 feet squared. Now, let's talk about the cylinder. The surface area formula for a cylinder is, I know this, pi r 2. There's two.
2 pi r squared plus 2 pi r h.
Oh my gosh, I know that. Do I swear? Plus 2 pi r h. But let's think about this shape. Okay, so the cylinder, we have a cylinder, and then we have the spheres on top, hemispheres, right? What is exposed? Is the top and bottom exposed?
No.
Watch your language.
Sorry.
Okay.
Heaven no.
Okay, the top and bottom are not exposed. So you need to understand the formula. What part of the formula is the two circles? The 2 pi r squared. The two circles is this part right here. We do not need that part because that is not exposed. We only need the side, which in the formula is 2 pi r h. 2 pi r is the circumference of the circle, right? Length times width. It's a rectangle. 2 pi r times h. So it should actually be 2 times pi times 1.5 times 8, which gives you 75.4. And when you add those together, 103.7 feet squared. Yeah.
I know you showed us this yesterday, or like a couple, like lessons ago.
Yeah.
How do you, like answers that are irrelevant into your next thing?
Okay, as long as it's the previous one, it has to be the previous. If it was the previous, second negative. Okay. Otherwise, if you want earlier stuff, that only works if you have a newer calculator. Then you can go up and literally whatever's highlighted, push enter, and it'll use that number. Okay? All right, one more example. My favorite. Okay, I want to get through this pretty quickly, okay? So, let's read the question this time so we know what they're being asked of us. The diameter of this solid cylindrical shape is 10 centimeters and its height is 6. Okay, so diameter is 10. Do we ever need diameter? What do we really need? Radius. So radius is 5. And height is 6. Okay, radius is 5. Okay, different colors might be, or actually I'm going to write the 5 up above. Okay, I'm going to go like this. I'll show you why in a second. Okay, now we want to cut a hole into this shape. Directly in the center of it, we drill a hole, diameter of 8, which really we want what? Radius of 4 is drilled right through this object from top to bottom. So what happens is we're going to drill a hole. Okay. Should be right in the center. Mine does not look right in the center, but sorry. I'll fix it. Close enough. Okay. So right through the center. And so the other one kind of had a diameter like this, right? It is like a toilet paper roll. Okay. What is the radius of this shape? 4 centimeters.
It actually
Big. A little big. Okay. Find the volume of the resulting object to the nearest tenth. So we want the volume of what remains. After we drill that other piece out, we're left with this beautiful toilet paper roll. How much toilet paper? What volume of toilet paper? Yep. Guys? Hey, do we need a new seating plan?
Yeah.
Okay, you're staying here.
Didn't you just find volume of the original cylinder?
Okay, so the volume of the large cylinder.
And then subtract the volume of the small cylinder?
Yes. That's it. Volume's a lot easier. Okay? So the volume of what remains is the original volume of the shape, the large one, before the hole was taken out, and then subtract the volume of the small, what we actually removed, and what's left over is the volume we're looking for. Okay? So that's going to be our volume. What is the formula for the volume of a cylinder? Pi r, so radius large squared times h, minus pi radius small squared times h. Because the radiuses aren't the same, right? They're two different radiuses. the two different cylinders. Are the heights the same?
Yes.
Yes. Okay, so we could do this in two separate spots, or we could do it all together if you want. Pi, what's the large radius? 5 squared, and the height was 6 minus pi times 5. What's the small radius? 4 squared times, the height is 6. Okay, type that in your calculator. To the nearest tenth. I'll type it in 2. Pi 5 squared times 6 minus pi 4 squared times 6. You don't have to put the time symbol, but you might want to. Between pi and 5 squared. Looks better. Okay, so, oh, that doesn't look like, right? Oh, I see it. That's better. To the nearest tenth, what does that round to? 169.6 feet cubed. Or centimeters? Thank you. Centimeters cubed. Como? Let's see that. I might have to. Okay, surface area. Now, let's talk about, it says calculate the surface area of this object if all surfaces are to be painted. Round to the nearest tenth. This one's tough. Including the inside. Okay, so let's break it down. We have, first of all, the shape on top, right? What shape is that actually? Yeah, so I'm going to actually just draw. Let's just view the top view. Top and bottom view looks like a circle and then a circle inside, right? And we want, oops, what do we want? The area of which part? The inside, well, we're going to need to find the inside, right? We need to find the big and the small, because what we really want is the yellow there, so we need to subtract them. Okay? And then, once I find one, is it the same in the bottom? Yeah, top and bottom are the same, so we can multiply it by 2. So, to find the area of the top, we need the area of the large circle minus the area of the small. So, large minus small again. What's the formula for the area of a circle? Yeah. Pi r squared. So pi r, so large radius squared, minus pi r small radius squared. With 2 circles. Okay, which gives me, well, pi times, what's the large radius? 5, and the small was 4. So again, pi times 5 squared minus pi times 4 squared. 28.3? Okay, well, I'm going to type it in my calculator just so that I can use the exact value later. Pi 5 squared minus pi 4 squared. 28.27. Units with centimeters squared. Okay, so what else is exposed on this shape? Oh, what else oh, one more step. Yes. Multiply by 2. Okay, why? Top and bottom. Right? They're the same. The top and the bottom's the same of the circle. So we're going to multiply that by 2 because there's 2 circles. So I'm going to grab my calculator. Times 2 gives me 56.548 ... centimeters squared. Okay, so there's the top and bottom. Now, what else is exposed area? The outside of the cylinder. So there's the outside, and then we're going to need the inside. So on the outside of the cylinder, we're just talking about specifically the rectangle that's formed. Where's my crayon? Here it is. So just the side portion here, this rectangle when you open it up. Just this side. So surface, what part of this formula for a cylinder, which is surface area is pi r squared plus, nope, 2 pi r squared plus 2 pi r h. Which part of this formula do we want? 2 pi r h. We do not need the two circles. We already taken care of our circle stuff, right? So we just want the 2 pi r h for that outside. What was the height of this cylinder? 6. And what's the radius of this large one? 5 centimeters. So surface area of the outside is 2 pi times 5 times 6. Or would you agree with 188.4955? Okay, and what else do we need to include? One more thing. The inside of the small, we want actually this portion here. That's too red. Right? This part here of our cylinder. So again, what part of the surface area formula do we want for the cylinder? 2 pi r h again. Just the 2 pi r h. We don't need the circle top and bottom. So then 2 pi, what's the radius of this guy? 4, what's the height? 6. Pi 4 6. 150.79. Dot dot dot. Okay, so the last thing we want to do, add them all together.
94.2.
Nope. Because the three numbers we're adding are 56 plus the 188 plus the 150. Okay. And do we want the nearest tenth? Yep. They take a lot of time, don't they? So it depends on the version. If you go up, and once it's highlighted, you push enter. So much easier if you. Isn't that cool?
But the TI-83s don't do it.
The 84s do. As long as, and if it doesn't, you can update your software for an 84. 83s don't. You'd have to store them as letters. Right? I showed you how to store things as letters before, haven't I? Yeah, so when you have a number, just store it as A, store it as B, store it as C, and then go A plus B plus C. That works too. So 395.8 centimeters squared when you add those three numbers together. So we added up this guy, and this guy. Those three. Pictures really help if you draw yourself a little picture. I need to see your work. This is a written response. It's usually going to be out of like 3 or 4 marks. And unlike your quiz was an exception. And so I'm looking for your formulas, your substitution, maybe even a picture if it's needed. Well, okay, at least your formula, substitution, answer, okay? I want to see this. Okay, see what I did? That's what I want you to do. Your mathematical work, it's a proof. This work is a proof. Proof to whoever looks at it, and they should be able to look at this and be like, follow your work and see, okay, yes, this is correct. Okay, so assignment is the handout that's in front of you. Okay, composite shapes. I'm going to stop the video.